In this question, it is given that let capital M be the maximum value of product of two positive integers when their sum is 66. Let the sample space S is equal to the set of elements X where X belongs to Z, that is set of integers, and X into 66 minus X is greater than equal to 5 and 9 M, and the event A is equal to X belongs to S and X is a multiple of 3. That is, A contains those integers which are multiple of 3 and belongs to the set S also. Then PA is equal to, you have to find the correct choice. You must know this concept that if alpha and beta are two positive numbers, then using the concept of arithmetic mean greater than equal to geometric mean, we can easily say that alpha plus beta by 2 is greater than equal to under root alpha beta. Note that I am saying alpha and beta are two positive numbers. From here it is clear that if alpha plus beta is constant, then say lambda, then using this formula I can say under root alpha beta is less than equal to lambda by 2, that is alpha beta is less than equal to lambda square by 4. And you know that arithmetic mean equal to geometric mean is possible only if alpha and beta are equal. That is, this will become equal to this if alpha and beta are equal. Otherwise, for unequal values of alpha and beta, this will be greater than this. Hence, if alpha plus beta is constant, then I will reach at the conclusion that alpha beta is less than or equal to lambda by 2 whole square. I mean to say, if alpha plus beta is constant, then the maximum value of product of alpha and beta will be lambda by 2 whole square, where lambda is the sum of alpha and beta. And this means equality will be possible when alpha and beta are equal. And similarly, I can say this thing also, if alpha into beta is constant, say mu, then according to this, alpha plus beta will be greater than equal to 2 under root mu. That is, the least value of alpha plus beta will be 2 under root mu, where mu is the product of alpha and beta. And you should know this thing also, that equality is possible when alpha and beta are equal. That is, when alpha and beta are equal, then alpha plus beta will become least, and least value will be 2 under root mu. To find the value of capital M, let alpha and beta are two positive integers, and using the concept of arithmetic mean greater than equal to geometric mean, I can say alpha plus beta by 2 is greater than equal to under root alpha beta. And because sum of alpha and beta is given to you as 66, hence I get 33 is greater than equal to under root alpha beta. That is, I can say alpha beta is less than equal to 33 square. And because this is less than equal to this, hence I can say this is the maximum value of product of alpha and beta. That is, I can say the value of capital M is 33 square. And now putting the value of capital M as 33 square, I get the conclusion that x into 66 minus x is greater than equal to 5 and 9 into 33 square. And now I will find all possible values of x such that x is a element of S. X will be element of S if x is an integer and satisfy this condition. This can be written as x into 66 minus x greater than equal to 5 into 11 into 11. Obviously, it is very difficult to solve this inequation by using quadratic formula. And to solve any quadratic inequation, say ax square plus bx plus c greater than equal to 0, and alpha and beta are the roots of this, then the conclusion is x is greater than the bigger root or x is smaller than the smaller root. And in case of ax square plus bx plus c less than equal to 0, supposing a is positive, the conclusion is the value of x lies between smaller root and bigger root. And similarly, if a is negative, in those questions ax square plus bx plus c greater than equal to 0 means the value of x lies between smaller root and bigger root. And in this case, ax square plus bx plus c less than equal to 0 means x is greater than the bigger root or x is less than the smaller root. Hence, to solve this quadratic inequality, first I will solve this equation x into 66 minus x is equal to 5 into 11 into 11. It is clear that the coefficient of x here will be negative. Hence, the solution of this will be the value of x is lying between smaller root and bigger root of this. But it is very difficult to solve this as a quadratic equation in x, because if I open it, I will get x square minus 66x plus 5 into 11 into 11 equal to 0, and finding the roots of this is a very difficult job. But you must know that because x is given to us as an integer, this is very helpful. Means I have to find an integer value of x, so that product of this and this is this. It's clear that if I take the value of x as 5, then I will have to take the value of 66 minus x as 11 square, which is not possible, because if I take x as 5, 66 minus x equal to 11 square is not possible, because in that case left hand side will become 61. Obviously, if I take the value of x as 55, then the value of 66 minus x will become 11. Hence, you can say one of the root of this equation is 55. And once one of the root of any quadratic equation is known to you, you can find the other root very easily by using the concept of sum of the roots or product of the roots. If I open this, I will be getting x square minus 66x plus 5 into 11 into 11 equal to 0. Hence, if 55 is one root, other root will be, say, lambda, then sum will be 66. Hence, the value of lambda will become 11. Hence, if 55 is one root, other root clearly becomes 11. From here it is clear. Otherwise, by common sense also, it was clear that if I take the value of x as 11, this will become 55. Hence, product will be equal to this. Therefore, other root will become 11. But the better thing is, once one root of the quadratic equation is known to you, you can take the help of sum of the roots, or you can take the help of product of the roots to find the other root of any quadratic equation. Hence, because I have got the conclusion that the roots of this are 11 and 55, hence the value of x becomes less than equal to 55 and greater than equal to 11. Hence the elements of S becomes 11, 12, 13, 14 up to 55. That is, I can say number of elements in S is equal to 45, and A is the set of those elements of S which are multiple of 3. Clearly, the set A will have the element 12, 15, 18 up to 54. And therefore, to find the number of elements in the set A, it is clearly an AP with first term as 12 and nth term as 54, and I have to find the value of n, and n will be the number of elements in the set A. Therefore, writing 54 equal to 12 plus n minus 1 into 3, I will get 42 upon 3 equal to n minus 1, that is n equal to 14 plus 1, that is 15. Hence the number of elements in the set A is 15. Obviously, P A will become 15 upon 45, that is 1 by 3. Hence I can say second choice is the correct choice.